Hello everyone. In this video, we cover the continuous life annuities. For continuous whole life annuity, the payment rate of $1 per year is made continuously until the death of an individual. Suppose the individual dies at this time point, then the payment is made from age X to age X plus TX. The payment rate is $1 per year. Let Y be the present value random variable for this annuity. We have Y equals to A bar angle TX. The expression for continuous annuity certain, we have 1 minus nu to the power Tx over delta. The expected value for Y, the expected value of this expression. The actuarial notation for continuous whole life annuity is A bar X, which equals to 1 minus the expected value of nu to the power Tx and then over delta. Delta is the force of interest. The expected value for the nu to the power Tx, this is simply the actuarial present value for the continuous whole life insurance, A bar X. And recall that, similar to the discrete case, the superscript 2 A bar X is not the second moment for Y. The variance, so we simply take the variance of this expression and we get 1 over delta square and then times the variance of nu to the power Tx and we get this expression. All right, the other way to get the A by X, so we use the formal definition, the integral from t equals 0 to infinity, and then the value for Y, A bar angle T, and then times the PDF of Tx. And then from this, we can get the expected value of Y squared. We can use the more convenient expression. For the discrete case, we sum up the actuarial present value of individual payments. And for this continuous case, we use integration. And then consider the small interval from time t to time t plus dt. The payment amount is dt because the payment rate is $1 per year. And here, the interval here is dt. So the corresponding payment is dt. The actuarial present value for this amount multiplied by NEX, or e to the power minus delta t, and then TPX. And we have this expression, a more convenient expression to compute the expected value for Y. And remember that the expected value for Y squared is not simply by changing delta to 2 delta with this expression. We must use the formal definition to get the second moment of Y. For the N-year temporary life annuity, the payments pays only up to the individual reaching age X plus N. Again, the payment rate is $1 per year. We have Y, the present value random variable for this annuity with this expression. If the individual dies within the N-year period, so Y depends on the time of the death of the individual TX. If the individual survives beyond the N-year period, Y is a constant at A bar angle N. The actuarial notation for this is given by this. And then the expected value for Y. The notation for the temporary annuity deal, we have A bar X colon angle N. The YZ relationship, this equals to 1 minus, and then the N-year continuous annuity, and then over delta. And the corresponding expression for the variance of Y. By formal definition, the expected value for Y, use integration, t equals 0 to t equals n, and then the integrand, the value for Y, A bar, angle T, and then times the PDF of Tx. And then plus the expression when the individual survives beyond the N-year period, we have A bar, angle N, and then times NPX. The second moment from the basic principle. Or using the more convenient expression to get the expected value for Y. So we have this expression, t from 0 to n, the integrand, e to the power minus delta t times tpx, and then dt. For the N-year deferred annuity, there are no payments during the N-year deferral periods. And this is the corresponding PDF of Y. The notation, M bar, and then A bar X. And we have this expression from t equals n to the upper limit is infinity. And then the N-year certain and life annuity. The payments are certain within the first N-year period, the N-year guarantee period, or N-year certain period. And we have this expression for the PDF of Y. Even if the individual dies within the N-year certain period, the individual will receive the payment from Hx to Hx plus n, that is A bar angle n for Y. And then after that, depends on the time of the death of the individual. The notation, A bar, and then the subscript X colon angle n with a bar above. And we have the expression to get the certain and life annuity. We have the annuity certain, A bar angle n, and then plus the N-year deferred annuity. All right, some relationships. Very similar relationship as for the discrete case. We have the N-year deferred annuity, the continuous annuity, equals to the whole life annuity at Hx plus n, and then multiply by the actuarial present value factor NEX. And then the whole life annuity equals to the N-year term annuity plus the N-year deferred annuity. And the N-year certain and life annuity. We have the N-year certain annuity here, A bar angle N, and then plus the N-year deferred annuity. Summary for the expectation, the expected value for Y. And then the relationship with insurance. For whole life annuity, we have the YZ relationship. The A by X equals to 1 minus big A by X over delta. And then the corresponding expression for the variance. Similar expression for the temporary life annuity. And then for the N-year deferred annuity, we simply take A by X and then minus A by X colon angle N, and we get this expression. Similar for the discrete case, the variance for the N-year deferred annuity or the expected value and the variance for the certain and life annuity, we get the value using the basic principle. All right, this is the theory part for continuous life annuity. In the next video, we'll move on to examples. Thank you very much for watching and see you in the next video.